The Earthing System Improvement Project. Recently, my household appliance suffered some costly damage because of voltage surge by the Power Utility Supplier, Tenaga Nasional Berhad. I did a check on the existing ground earthing copper rod in the earthing chamber. I use a digital earth resistance soil resistivity tester meter which consists of 3 probes with spikes, with 3 long wires colored red, yellow and green. A digital earth resistance soil resistivity tester meter is an instrument used to measure the resistance of the earth electrode and soil resistivity. It works on the principle of injecting a current into the soil through the earth electrode, and then measuring the voltage drop across the electrodes to determine the resistance. The meter typically consists of a transmitter and a receiver. The transmitter generates a constant AC current, which is sent through the earth electrode and into the soil. The receiver measures the voltage drop across the electrodes and calculates the resistance. To measure soil resistivity, the electrodes are placed in a line or a grid, and the transmitter sends the current through one electrode and measures the voltage drop between 2 or more other electrodes. The distance between the electrodes and the voltage drop are used to calculate the resistivity of the soil. The instrument is commonly used in grounding systems, lightning protection, and electrical safety testing. The distances to drive in the spikes into the ground are shown in the diagram below. Before the project, the ground resistance of my existing copper rod electrode was 28.2 ohm, which is excessive. The Tenaga Nasional Commission handbook states that the ground resistance of the ground copper rod must be not more than 10 ohm. This DIY project consists of the following: 6 copper rods, Blackburn brand, each 5 feet length, costing Rm 17.50 each. 6 copper couplings to join the copper rods, Rm 9 each. 3 copper rod clamp, Rm 9 each, to clamp the earth wire to the copper rod. 4 meters of 10 mm mega cable, Rm 6 per meter. Earth chamber, Rm 12. 10-pound steel hammer. Charcoal powder to improve the conductivity of the soil. Plastic casing to shield and protect the earth wire. When the project was completed, the ground resistance of the copper rods improved tremendously. It dropped from 28.2 ohm to now only 2.0 ohm. This is a huge improvement. This means that in the event of power surge or lightning strike, only 2% of the excess current will pass through the household circuit, 98% of the excess current will be drained into the earth or ground. I am glad that this DIY project was done. Praise the Lord.